Every Python developer, at some point, stares at a perfectly good piece of code, hits run, and gets an indentation error. You know the one. It is Python's way of telling you, very directly, that you have messed up its invisible syntax. Today, I want to show you exactly why that happens, and how to make sure it never trips you up again. Imagine a programming language where whitespace is not just for making your code pretty, but it is the actual structure. It is the difference between a legal contract with numbered clauses and subpoints, and just a wall of text. Python chose the contract. This design solves some problems, like forcing readability, but it creates new ones for you if you are not careful about every single space. By the end of this, you will know how to structure your code blocks with precise four-space indentation, avoiding those frustrating errors. You will also differentiate Python statements from expressions, understanding when your code performs an action versus when it evaluates to a value. This distinction is critical for writing robust logic. Beyond that, I will show you how to leverage comments and docstrings for robust code documentation, making your code understandable for anyone, including your future self. Finally, you will gain precise control over your console output using the print function's advanced arguments, letting you format text exactly how you need it. Let us start with Python's most distinctive feature, indentation. Think of it like a blueprint for a building. The walls, the rooms, the floors, their relationships are defined by their position and how they align. In Python, the interpreter uses leading whitespace, specifically indentation, to delineate code blocks. This replaces explicit delimiters like the curly braces you might see in C++ or Java, or begin/end keywords from Pascal. The standard, which is not just a suggestion but enforced by PEP8, mandates exactly 4 spaces per indentation level. This is non-negotiable. A code block, for instance, after an if statement, a for loop, or a def function definition, begins after a colon. It continues as long as the indentation level is maintained. When the indentation returns to a previous level, that block has ended. Here's what that looks like in practice. I am going to declare an integer, let us say x, and set it to 15. Then, we will write a simple conditional block to check its value. First, integer x is 15. Then, we have if x greater than 0 colon, followed by a colon. The next line, print parenthesis, quote, positive quote, close parenthesis, is indented 4 spaces. This tells Python it is part of the if block. Then, if x greater than 10 colon is indented another 4 spaces, making it nested inside the first if. Its print statement, print parenthesis, quote, large quote, close parenthesis, is indented a total of 8 spaces. Finally, the else colon statement aligns with the first if, indicating it is an alternative to that initial condition. Its print parenthesis, quote, non-positive quote, close parenthesis is again indented 4 spaces. When you run this code with x set to 15, you get exactly this on screen, positive, and then large. Now, here is where it gets interesting, and where you are going to run into trouble if you are not careful. Python absolutely forbids mixing tabs and spaces for indentation within the same file. I have seen this trip up so many new developers, and even some experienced ones who copy-paste code from different sources. If I take that exact same code, but for the print parenthesis, quote, large quote, close parenthesis line, I use a tab instead of 8 spaces, Python will throw a tab error colon inconsistent use of tabs and spaces in indentation. The interpreter cannot determine the block structure reliably when you mix them, so it just gives up. You must pick one and stick to it, and the standard is 4 spaces. Now that you understand indentation, statements and expressions are going to make perfect sense. An expression, at its core, evaluates to a value. Think of it like a mathematical equation. 5 plus 3 is an expression because it gives you the value 8. X greater than 0 is an expression because it gives you either true or false. A statement, on the other hand, performs an action. It does something. X equals 42 is a statement because it assigns the value 42 to the variable x. A for loop is a statement because it iterates over a sequence. You cannot assign a statement to a variable because a statement does not produce a value to be assigned. Let us look at some concrete examples. Y equals 10 times 2 is an assignment statement. The 10 times 2 part is an expression that evaluates to 20. The entire line, y equals 10 times 2, is a statement. Print parenthesis y close parenthesis is also a statement, performing the action of outputting to the console. The y inside the parentheses is an expression, evaluating to the current value of y, which is 20. Python also has conditional expressions, sometimes called ternary operators, which are quite powerful. Result equals quote positive quote if y greater than 0 else quote non-positive quote is a single expression that evaluates to either positive or non-positive based on the condition. This entire line is an assignment statement, but the right-hand side is a conditional expression. When you run this, with y being 20, you will see value of y:20, and then result positive. The key takeaway is that you can embed expressions inside other expressions or statements, but you cannot embed a statement where an expression is expected. For example, you cannot write z equals if y greater than 0 print parenthesis quote hello quote close parenthesis, because the if statement does not return a value. Now, let us talk about making your code readable for humans. Comments are your notes to yourself or to the next engineer who has to touch your code. In Python, a single-line comment starts with the hash character, hash, and extends to the end of that line. The interpreter completely ignores everything after the hash. Python does not have a dedicated multi-line comment syntax like ***/ in C++. Instead, we use triple quoted strings. If a triple quoted string is not assigned to a variable, it acts as a multi-line comment. More importantly, when placed immediately after a function, class, or module definition, it becomes a docstring. Here is a function I wrote, calculate_area, which takes length and width as arguments. The first line inside the function is a triple quoted string. Triple quoted string calculates the area of a rectangle, returns the product of length and width. Triple quoted string. This is a docstring. It explains what the function does and what it returns. Below that, #this is a single-line comment explaining the calculation, is a standard comment. It clarifies the return length times width line. When you call help calculate_area close parenthesis, Python will display that docstring. This is incredibly useful for automated documentation and for anyone trying to understand your API without reading the source code. If you run this code, it will print, the area is :50. The comments and docstrings are completely ignored by the interpreter during execution, but they are invaluable for maintainability. A common mistake is using multiple hash lines for a multi-line comment when a docstring would be more appropriate, especially for function explanations, because docstrings are programmatically accessible. Finally, let us talk about the print function. This is your program's voice to the outside world, how it communicates with you. You have probably used it already, but there are some powerful arguments you might not be aware of. The built-in print function outputs text to the console, and it accepts multiple arguments. By default, print function separates multiple arguments with a single space, and it adds a new line character at the end of the output. This behavior is customizable using the sep and end arguments. Under the hood, print function writes to sys.standardout, which is the standard output stream, and you can even redirect it if you need to capture output to a file or another stream. I am going to show you how sep and end change the output. First, print parenthesis quote hello quote comma quote world quote close parenthesis. This will print hello world because the default separator is a space and it adds a new line. Next, print parenthesis quote a quote comma quote b quote comma quote c quote comma sep equals quote comma space quote close parenthesis. Here, I am explicitly setting the separator to a comma followed by a space. This will output a comma b comma c. Notice no extra space at the beginning or end, just between the items. Finally, print parenthesis quote the end quote comma end equals quote exclamation mark quote close parenthesis, and then print parenthesis quote next line quote close parenthesis. The first print statement uses end equals quote exclamation mark quote, replacing the default new line with an exclamation mark. So, the end exclamation mark and next line will appear on the same line, like this, the end exclamation mark next line. This is crucial for building custom formatted output strings without manual concatenation. You have now mastered Python's core structural elements. You understand that Python's indentation is not just stylistic, but a fundamental part of its syntax, defining code blocks with exactly 4 spaces. You can distinguish between statements, which perform actions, and expressions, which evaluate to values, a critical concept for writing correct logic. You also know how to effectively use single-line comments with hash and leverage triple-quoted strings as docstrings for automated documentation. And you can now precisely control your console output using the sep and end arguments of the print function, giving you fine-grained control over how your program communicates. Next time, we get our hands dirty with the actual building blocks of every program, variables, and dynamic typing.